midpoint Riemann sums. Sweet. So, let's take a peek at some graph. Let's go to my graph. Here we go, we got some graph. And we'll do our y equals x squared. This will be 1.
Are we turning this over?
This will be 1. Nope, Ewa checked it, so I'm good. So we've approximated this with a left hand and a right hand. Let's just do it with a midpoint. And all midpoint means is it just means we're going to take the middle of our interval to get our height. So let's look at this. Let's say I wanted to do this with a midpoint with 5 subdivisions. So y equals x squared, midpoint with 5 subdivisions. Okay, so 5 subdivisions. Brianna, what would be the width of each interval slash, more importantly, how do I calculate what would be the width of each subdivision, but more importantly, how do I calculate the width?
Midpoint.
Isn't
I got 5 subdivisions.
it 1 minus 0, 5, which gives you 1/5?
Brianna, you're awesome. So, intervals from 0 to 1, so we go 1 minus 0, that's b minus a over 5, so we have a width of 1/5. That's equal to our width. Cool. Now, let's look at this graphically, 5 subdivisions. So, okay, here, we're going to do all these rectangles. But I'm saying it's a midpoint. So Yasmin, I'm going to take the middle of this rectangle, and I'm going to draw it up to here, here, and then I'm going to take the middle of this one, and I'm going to draw it to here.
What are you doing?
Oh, he's drawing the
You'll
middle
see
of the
it.
rectangle.
So before I would take like the left, Yasmin, I'd bring it all the way up, and then over till where the left hits. But now what I'm going to do is I'm going to take the middle of it, and I'm going to bring it up, and see where it hits. You guys will see in a second. So if I look at this rectangle right here, if I did a left-hand Riemann sum, I'd go up to here and over. If I did a right-hand Riemann sum, I'd go up to here and over, right? This is going to be a midpoint Riemann sum. So I'm going to find the middle, that's right here, and that's going to be my height. Then I'm going to draw it down and draw it down. Does that make sense, guys?
Of left and right?
So it's just called a midpoint Riemann sum. It's not a left Riemann sum or a right.
But I'm saying, is it the middle of the
Is
left?
in between the left and right?
Yeah, exactly.
I think
It's you take this value and you see what its y value is. So to be really clear, this is 0, this is 0.2, right? This is 0, this is 1/5, right? So in the middle of 0 and 0.2 is 0.1. Do you agree with that? So the height of this is going to be f of 0.1. And I'll really show you that in a second. All right, let me just show you graphically.
Is it more exact then?
Yeah, it's the best estimate of those 3. All right, so that's what midpoint looks like graphically. All right. So Janelia, if this is 0, this is 0.2, that's 1/5. This is 0.4, this is 0.6, this is 0.8. The x value, which I want to evaluate at, would be 0.1, because it's the middle of 0 and 0.2. Does that make sense, Dan?
What did you just say? So you find that
I should have done less
you
less subdivisions, yeah.
divide the distance by half.
Yeah, I mean, if the width is 1/5, you divide that in half, that's 1/10. This is 0.1. So the middle of 0.2 and 0.4.
Whatever, it's going to be
In the middle.
between.
Mm-hmm. In the middle. So let's look at this. I just want you guys to understand it conceptually. Our width is going to be 1/5 for all of them, right? Now let's tally up all our heights. The first one, it's going to be f of what? F of 1/10. I just said interval from 0 to 1, sorry. I didn't actually do it. Okay. What would the second one be, guys?
So where did 1/10
Yep.
come from?
3/10.
It's 1/10 is the middle of 0 and 0.2.
3/10.
What's that, Christian?
Is that equivalent to 0.1?
Yeah, f of 0.1, exactly. Yeah, and since I did these in decimals, I'll do this in decimals, sure. F of 0.1. Okay, plus, Jab, what's the middle of 0.2 and 0.4? 3/10 or 0.3, right? Okay, plus, middle of 0.4 and 0.6. Brianna?
0.5.
0.5? All right. And then Tatiana, what's the next one?
0.7.
0.7. And the last one, Pete?
0.7. 0.9.
0.9. Awesome, awesome, awesome. Does that make sense, guys? Cool. Sweet, 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 sweet. All right. How could we evaluate that fast and efficiently in the calculator, guys?
Put it in the graph book.
Put y equals x squared into our function, into our y1, right? And then go to the table and then get all those boom, boom, boom. With sigma notation, you can do it even faster. Everyone do it and let's check your answers. So approximate this area under the curve. And then we'll check our answers. Go, go, go.
Is it always f of the height?
F of the x value to get that height. So it's always f of this x value right here.
It's a good thing you're looking
F
at.
of 0.1 is going to
I think you could.
be. So f of 0.3 would get
Plug in the point here.
that's that right there.
You can do sigma notation.
So 0.3. Okay. So
Maybe put 5 points in those two.
You already know the answer.
What is this? How'd you get it from this?
sup shit.
How do you get from this?
Wait,
I mean, now you put it in. I got
Tap. Stop.
Alright, so you go to
So you add those.
page that together, then we'll run. Which doesn't seem that fun.
First person to get it gets a point.
Okay.
Point. Oh, who has it? You have it?
I think I
Corinne, Corinne, yell it out if you're good.
I have 0.33.
Corinne says 0.33 is her approximation for the area. 1/3. It looks about 1/3.
That's what I got.
Christian, have you had that already? All right, Christian and Corinne. Dos puntos. One
No.
pera each.
I'm pretty sure that's not how you say points.
Yo, punto is how you say point.
Yeah, it is.
Okay.
Oh, never mind.
And
You
then
thought I
you-
made that up?
Oh,
Yo, yo, hablo español.
no, I said something else.
Christian.
You might want to see that hope on
All right,
I got 0.4.
can we take a serious poll?
Stop using sigma notation.
Could I or could I not pass for a high school student?
Yeah.
Well, you're not.
You be borderline senior.
Borderline senior? Wait, so you might think I might be a junior this
You'd be
time?
one of those seniors that, you're like one of those seniors that got held back senior.
Yeah, like you
Ah.
look
Been here.
like a senior that stayed
At
back.
another high school, yeah.
Another high school. Pete's argument was, no, I'm too tall to be a senior, and I was
That's
like,
why I'm thinking
Yeah.
here, but I think at
You're
another high
tall.
school.
You're
But-
super
You'd be
senior.
surprised.
but I was this tall my senior year,
5
Like
years
a
in.
fifth
That's
year
crazy.
senior.
right?
I would say
Look at Corinne. Corinne's been this tall since like freshman year.
I would say another high school.
I got 0.4.
All right. So guys, we're good. We understand that.
Yep.
I don't know how to put it in the calculator. I don't know how to do that.
Okay. Okay. To put it in the calculator, real quick. Let me hit it.
Could you do it
I got
in sigma
0.33.
notation for me?
I will go one-on-one with sigma notation. I really don't want to waste.
I still keep doing it that way.
So y equals x squared is our function that we're using. Shayna, right? So we're gonna throw that in our y1. Then you got to go to second table set. That's above window. And you need to go to independent variable. You want to set it to ask, so that way you can put in whatever independent variable you want. And then the dependent variable is on auto. It will give you back the dependent variable, the y, the output, right? So then we go to second table. I went to graph accidentally again. And now I'm going to put in the things I want. I wanted 0.1. I wanted 0.3. I wanted 0.5. I wanted 0.7. And I wanted 0.9. and I really messed that up. Second table. 0.1, 0.3, 0.5, 0.7, enter, and 0.9, enter. Okay. So those are the values. Shannon, does that answer your question? Sweet. Huh?
Then what do you do?
Now you get it.
Add them up.
Add them up and divide by
Divide by
No, you multiply by 1/5.
Add them up. Divide.